So next we have the magnitude of the vector. So again, from yesterday, from 8.1, the magnitude of the vector is its length. So if you're given the terminal and the initial points, all that you're doing is you're finding the distance between those points. So it is the distance formula, okay? And technically you should do the terminal point minus the initial point, but because it's the distance formula, it actually doesn't matter, okay? If you have the vector already in component form, all that you actually have to do is the Pythagorean theorem, okay? Because these are the rectangular components, and so a squared plus b squared equals c squared. Again, we're finding the distance of that hypotenuse, we're finding the distance of that vector. And so if you're given the initial and the terminal points, distance formula. If you're given it the vector already in component form, it's just the Pythagorean theorem, okay? So find the magnitude of vector AB given the initial point of -2, -7, and the terminal point of 6, 1. So I'm going to go through and do the distance formula. So the magnitude of the vector is going to be the square root of 6 minus a -2 squared plus 1 minus a -7 squared. So I have the square root of 8 squared plus 8 squared, or 64 plus 64, or the square root of 128. 128 has a perfect square factor of 64, and so I get 8 square roots of 2. Find the magnitude of vector A, given that vector A is equal to the vector 3, 4. So the magnitude of A would equal the square root of 3 squared plus 4 squared. And if you already recognize that this is going to be a 3, 4, 5 triangle, you can certainly go right to that, but I'm going through the whole process here. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5.